Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is merge nodes in between zeros. Okay, so the problem statement goes like this. You will be given a head of a linked list, okay, and which contains a series of integers separated by zeros. Okay, so the beginning and the end of the linked list will have zeros. Okay, for example, in this linked list, if we take it to the board, let me open the board. Yeah, as you can see in this particular linked list, the first and the last node are zeros. Okay, so there might be some zeros in between, and what you have to do is between every two consecutive zeros you have to merge all the nodes lying between them such that they will be merged into a single node whose value is the sum of all the merged nodes. For example, these were two zeros, so we merged all the nodes lying between them, and the resultant node will be having value equal to the sum of values of these two, so it will be equal to 4. Similarly, if we merge all these nodes, since they were lying between two zeros, so if we merge them, we will be adding them. Okay, 4 plus 5 plus 2. Okay, so it will be 11. And what you will be doing is you have to return the modified list such that it should not contain any zeros. So 4 and 11 will be the modified list, and it will be not containing any zeros. Okay, so you have to return this list. So this is what you have to do in every input that is given to you. So let's have a quick look at the constraints also before thinking of an approach. So according to the constraints, the number of nodes in the list is in the range 3 to 2 into 10 raised to power 5. Okay, and each node value is between 0 to 1000, and there are no consecutive nodes with nodes 0 values. So the scenario, this kind of scenario will not happen, that if there are two zero containing nodes and there are no nodes in between them. Okay, and the beginning and the end of the linked list will always have nodes having 0 values. So as you can see in this example, the start and the end will always be having nodes of 0 values. Okay, so these are the constraints. So let's think of an approach. So a very first approach that is coming to my mind is we can use a two pointer like approach. So what we will be doing is, let me clear the board a little bit. First of all, you will be having two pointers. One will be previous 0. This will be pointing to the previous 0 that you have encountered. Initially, it will be set to head because as mentioned in the problem statement, the first and the last nodes will always have no value equal to 0. So we can set it to head, and these will be the references to the nodes, and another pointer will be current node. Okay, so this pointer current node will help us to traverse the whole linked list. And let me clearly mark the links here because they were marked in black, so they are not visible here. Now they should be visible. Okay, so this is the list that is given to you. Initially your previous 0 will be pointing to this node. Okay, and your current node will be here. So this current node pointer will go on from left to right and help us traverse the list in this manner. Okay, so what we will be doing here is, first of all, you would like to know that if your current node is at a node which is not 0. Okay, so it will be better if I take the code also, so that we can take up less time in the whole video to explain the approach and the code. So let's bring the code also. I think it will not be, it will be hard to adjust the code here. Anyways, I'll explain the code later. So let's keep continuing with this simulation kind of thing. So when the current node will be traversing from one node to another, let's say you are at a node which is not 0, then what you will do? You will keep your previous 0 pointer at its current position, which is pointing to the previous 0. Then you will keep adding the nodes till you encounter a 0 node values. Okay, so you will have another variable sum. So sum will have now 4. Okay, when your current node will be at 0, you will stop. Okay, so what you will do now, you will change the previous zero's next value, which is this node. Its value will be changed to value of sum. Okay, so the list will look something like this. Okay, once you have changed this node's value, you will also change its next pointer. So this will be also breaked and a new pointer will be made. Next pointer, it will be made to point the fresh 0 that we have encountered. Okay, so this is the second step. So the first step what we did was, as soon as we saw a node which was not having 0 value, then we keep adding the nodes till we reach another 0 value, and after having the sum, we just put the value of that sum in the next node of previous 0, which was 3. Okay, once it was having that value, then its pointer to the next node was breaked and it was pointed to the new 0 that we found. Okay, so it is the new 0 that we found and its pointer was changed. So your list is looking something like this right now. Okay, and also you would also like to now update your previous 0 since you have encountered a fresh 0. So your previous 0 will also be changed. So your previous 0 will be this. Okay, so now moving forward, your current will again be at a node which is not 0. Then again you will initialize a variable sum and keep summing all the numbers that you encounter which are not 0 as your current pointer moves one by one. Okay, so your sum will have value 11 when you will be reaching, current pointer will be reaching at this 0, which is the last 0 by the way. Okay, so now once you reach the last 0, what you will be doing is you will be doing the same procedure. So this 11 value will update the value of next node to the current previous 0. So this node was the next node to the previous 0 and its value will be changed from 4 to 11. Okay, and similarly as we have done in the previous step, you will break this pointer and update it to the current 0, and also your previous 0 will be updated. So previous 0 will no longer remain here, it will come here. Okay, and when you will terminate the whole process, as soon as your current node reaches the null value, so this was not having any next node, so as soon as your current node reaches null value or the end of the linked list, you will stop then and there. Okay, so this is the whole approach. Let's have a quick look at the implementation also. So let's take a fresh slide. I think this should be good. So let's bring the code here. Okay, let's copy only the code, not the comments. Okay, so this is the code. So what we are doing here is, yeah, I completely forgot. So once you are having this kind of structure, okay, then you might also want to remove these zeros. Okay, so for that there is one additional step that you have to do. Although we could have done it in a single pass, but just for the sake of clarity how things are going on, I decided to break it into two parts. You can also try it in single pass. So what we will be doing here is, we will be having a dummy node. Okay, and it can be initialized to any value that you may prefer, and your current node will be now made to point this node. Okay, and you will somehow make the arrangement such that dummy node will be pointing to the current head. Okay, so it was the head that was given to you. So this current node will keep traversing like this. Okay, so this way it will keep traversing till it reaches the end of the linked list, which is a null value. Okay, so what you will be doing now is, as soon as you encounter a value that is 0, a node having 0 value, so current nodes next was having, first of all you will check what is the next node of the current node. So if the next node of the current node is a value that is having 0 value, so you will not take that value, you will update the next of the current node to the next value, which is this value. Okay, and then your current node will also be changed. So things will go on something like this. So this pointer is updated. Okay, and your current node is here. So as soon as your current node see that the next value is a 0 value, again your pointer will be updated. So this pointer will be changed and it will be made to 0.11. Now your current node will be reaching the next value, which is 11. Okay, so as soon as this current node reaches the next value, you will keep continuing this process, and at last you will be having something like this dummy node. Okay, and then the next node will be 4 and the next node will be 11, and at last it will be null. Okay, so you will return the next of the dummy node, so you will return something like this. Okay, see, so this node was the next of the dummy node, so you will return this as your answer. So this is how you will be able to remove all the zeros also. So now let's continue with the code. So as I mentioned, we need two pointers, the previous 0 pointer and the current node. This node will be helping us to traverse the list. Okay, and previous 0 will tell us what was the reference or the address of the previous node at which 0 was encountered. So we will do a single traversal, linear traversal till the end, till we reach the end of the linked list. Okay, so as I mentioned, whenever you are at a node whose value is not 0, then you will start summing the values of the nodes till you reach a fresh 0. Okay, so till your current node's value does not become 0, you will keep summing the values and your current node will keep proceeding further. Okay, So once you are at a node which is having a 0 value, you will stop there. Then you will do the updation of the previous node's next value. So this updation will be done. Okay, so this updation is done here, and then the updation of the pointer of that node will be done here. Okay, so this change of pointer and its updation will be done at this step. Okay, and then you will update your previous 0 to your fresh 0 containing node, which is pointed by the current node. And at each step, irrespective of the fact whether you have encountered a non-zero or not, you will keep moving your current pointer by one place ahead. Okay, and now for the removal of zeros from the list, you will use a dummy head, as we have shown here. Dummy head or dummy node will be used. It will be initially made to point to the head. Okay, so its next will be initially made to point to head, and a current node will be starting from the dummy head, and it will progress further down the list till you reach the end of the list. Okay, as soon as your current node next is a 0 value, you will update the next to one node ahead. So this is what we are doing here. As you can see, this was a next value was 0, so we just updated the next link. Okay, the current link was updated to the next node ahead of the 0 node. Okay, so this is what we are doing here, and at each step, irrespective of the fact whether your next node is 0 or not, you will keep moving this current node one step ahead till you reach the end of the linked list. Okay, so then you will simply return the dummy head of your next node to the dummy head, which will be your required head or new head, you can say. Okay, so this is how you will be solving it. And as far as time and space complexities go, time complexity wise, it will be order of n, where you can say that n is the number of nodes. Okay, and space complexity wise, as you must have seen that we are not using any extra space, just defining one node, so it is pretty much constant. It is constant indeed, and we are just using some pointers and updating some links, so we are safe to say that it is constant order of 1. Okay, so these will be the time complexity and space complexities. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. Try to solve it in a single pass. If you are not able to do so, then I will happily provide you the implementation. And I hope this solution walkthrough added some value to your journey of honing your DSA skills. Till then, keep practicing more problems, and I will see you in the next video. Thank you for watching.